Okay, now let's look at problem number 15. So number 15 says we randomly choose 3 numbers from the collection of 5 numbers, 1, 3, 5, 7, 9. The question is, what is the probability that these 3 select numbers can be side lengths of a triangle? Okay, so first let's recall the definition, the formula, how we calculate probability. Right, so for the typically, the probability is just a fraction, which is the denominator is the number of total cases, and then the numerator is the number of those valid cases. Okay, so here, let's first figure out what's the number of total cases. So that means I have 5 numbers, I randomly choose 3, what are all the possible combinations. Now, there is a formula to calculate that, but for now, let's not worry about the formula, we'll just do by hand, manually, okay? So what's the number of all cases? We are going to do just manually. Okay. All right, so we start from 1, 3, and then the combination can go with 5, 7, 9, right? So we have 3 possible ways. So this is 3. So what I mean is for this, we can go 3, 1, 3, 5, 1, 3, 7, or 1, 3, 9, right? You can do that. Or let's go 1, 5. Then we have 7 and 9. So this is two possible ways, right? So it's 1, 5 to 7, 1, 5 to 9, okay? Then we can also do 1, 7, and then there's only 9 right here. So this is one possibility. Okay, now we can do 3, 5, then it's 7, 9, right? 7, 9, okay? So we have 3, 5, 7, 3, 5, 9. So this we have 2 ways, right? 2 ways. Okay, so then we also do 3, 7. And then we can go with 9. So that's only one way. Well, so this is 9. So there's only one way, right? So this just means 3, 7, and 9. Okay, so then we also have 5, 7, and 9. So we have 5, 7, and 9, right? 5, 7, and 9. So that's also one possibility. Now, if we add all those together, so here we have, you see we have 3, 2, 1, 2, 1, 1. So let's add them together. So it's 3 plus 2 plus 1 plus 2 plus 1 plus 1. So what we have, we get it's equals to 10. So there are 10 different ways. So the total number of possibilities, so this one is 10. Okay, so here we figure out the total number of cases is possible cases 10. Now we need to figure out the number of valid cases, right? Okay, so in order for 3 numbers to be a valid case, that means they can be side lengths of a triangle. Now let's recall, so given a triangle, we have a basic relation between 3 sides, that is A, it's B, it's C. We must have A plus B is greater than C. Okay, so the point is given a triangle, regardless what it is, the sum of 2 sides has to be greater than the third one. All right, so then we say, okay, in order to satisfy this relation, then we have, let's look at all possible valid cases. So we have 3, 5, 7, so this is a valid case. And then we also have 3, 7, 9, this is also okay. And the last possible one is put it here, so that's 5, 7, 9. All right, so in total, we only have 3 valid cases. So that's what we have. So that's why, so here we put is 3. So 3 cases, 3 valid combinations. So then the answer will be 3 over 10 because probability by definition is a fraction. So it's the valid case divided by the total number of cases. All right. Okay, now let's look at problem number 16. Okay, it says Molly practices exactly one sport each day of the week, and there's some rules. It says she runs 3 days a week, but nap on 2 consecutive days. So for convenience, I put R as means the running. Okay, so and on Monday she plays basketball, so B means basketball. And golf, the G means golf. Okay. And then S means swing. Okay, so and T means tennis. All right, so running is three run. Okay, so she runs 3 days, right? So 3 days, not on consecutive 2 days. Okay, so let's draw a table. Right, so we have this is Monday, and then this is Tuesday, Wednesday, Thursday, Friday, okay, and Saturday, and then Sunday. Okay, so first we know that on Sunday she plays basketball, so this is B, basketball. And then 2 days later she plays golf, so on Wednesday is golf. Now for running, 3 runnings, right? So 3 days on running. Now because running, according to the problem, she cannot run on 2 consecutive days. So that means this one must be running. Otherwise, if you put all 3 runnings here, then regardless how you arrange them, there must have 2 days that she runs. So that this violates the requirement. She cannot run on 2 consecutive days. All right. So then we have okay. So now let's accommodate the other 2 runnings. So we can have run like this, right? And we can have run like that. We can have run like on Friday or Sunday, right? Friday, Sunday. Okay. Now, if you do this, so we can let's look at a case by case, right? We do that. All right. Now, if you do this, if you go with this one, then you will have this swing and tennis will be right here, right? So you have three swing or tennis, swing or tennis. But here says, according to the requirement, she never play tennis the day after swing or running. So for this is going to violate. So this is impossible, regardless how you arrange that. The swing, the tennis will either be after swing or after running, right? So this is impossible. Okay, so how about this one? If we do this, we'll get the swing, because swing is tennis is cannot be after running. So the tennis must be here, and swing is here, right? So swing is here. But this is also impossible because then tennis will be after the running, so which is impossible. So this is also violate that. Okay, so now, so the last one, what we have is 2 running on this situation. Then what we can have, because we call the tennis cannot after running and the swimming. So that's the key requirement. So the tennis has to be right here. So this has to be the tennis here, and the swing will be right here. Now for this one, if you check, okay, so all requirements are fulfilled. So this one is okay. So this is a valid arrangement. Okay, so then we have the swing is on Saturday, right? So we get okay. So this is the valid requirement, and swing is on Saturday. All right. Okay. Now let's look at problem 17. So problem 17 says there's a round check. We have 3 cards. So this card 1, card 2. So this is 1, 2, 3. The first one needs 8 seconds. 8 seconds to finish the circle. And the second one is 10 seconds. It's slower, 10 seconds. And the third one is 12 seconds to finish a full circle. Now, of course, like if they just keep running along this round check, the question is, what is the first time, right? After how many seconds, they will simultaneously get back to the starting point. So let's say this is their common starting point, and they all go in this direction. Now you see, in order, so let's say this after time t, so this is the time, right? So you see, look at car 1, right? It takes car 1 8 seconds for 1 circle, then 16 seconds for 2 circles, and 24 seconds for 3 circles. So the point is, the time that the car 1 needs to finish a certain number of full circles, must be multiple of 8, right? Okay, so then the time we get the first one has to be multiple of 8, right? Okay, because eventually what we want is after they're running for a while, they all go back to the starting point. So that's several full circles. Now, okay, so this is for car 1. Now for car 2, it's similar. The car 2, when finish one circle, 10 seconds. So if after several circles, must be multiple of 10, right? So 10 seconds for one circle, 20 seconds for 2 circles, right? 30 seconds for 3 circles. Okay, so the time must be multiple of 10. Meanwhile, multiple of 10. Okay, so then we have for car 3, car 3 takes 12 seconds to finish one circle. So again, 24 seconds to 2 circles, but in order to go back to the original point after several rounds, so there has to be several full circles, right? So again, this has to be multiple of 12. So that's for car 3. So the point is, it has to be, so conclusion is, it has to be a multiple of 8, 10, and 12 simultaneously. So here's the conclusion, right? The conclusion is the time has to be the common multiple. The common multiple of 8, 10, and 12 in order for 3 of them simultaneously after a while they go back to the original point. Now, because here we are looking for the first time, so that means the least amount of time, okay? So least amount of time, we translate to this language means the least common multiple. So after this, we get, okay, so what shall be the time? So we get the time is the LCM of these 3 numbers, 8, 10, and 12. So this is the least common multiple, right? It's the least common multiple. Okay, so at this point, we need to find the least common multiple of the 3 numbers, 8, 10, and 12. So which means we need to find the smallest number that is the multiple of all these 3 numbers, 8, 10, and 12. Okay, so there's a general algorithm to find the LCM of several numbers, but we are not going to use that advanced tool. So instead, we just use a primitive approach. That is, I just look at multiples of 12. We start from 12 and then go to 24 and we go up and we look at one by one until we find the first number that is a multiple of both 8 and 10. And then we find the least common multiple of all the 3 numbers. Okay, so what I mean is the following. So we're going to use a primitive approach. Okay, so I'm going to list multiples of 12. So we start from the first one is 12. The second one is 24 and 36, 48, 60, 72, 84, and then we have 96, 108, 120, and 132, and such and such. All right, then start from 12. Let's see whether they are also a multiple of 8 and 10, right? So, okay, so we need to see whether they are also a multiple of 8 and 10. Now, 12, no. Okay, so this one is not a multiple of 10. So first, let's see which are multiple of 10, right? So which is more convenient. Okay, so clearly we have this guy is a multiple of 10, and this is also a multiple of 10. Well, but nevertheless, this is not, 60 is not a multiple of 8, right? So that's so 60 is excluded. So let's look at 120. So 120 is a multiple of 12, and it's also a multiple of 10. And we see it's also a multiple of 8, right? So 120 divided by 8, which is 15. So 120 is the first number that is a multiple of all these 3 numbers, 8, 10, and 12. So we conclude. So from here, we conclude 120 is the least common multiple of these 3 numbers, 8, 10, and 12. So this is the answer of this problem. In other words, after 120 seconds, which is equivalent to 2 minutes, right? So those 3 cars, they will all go back to the starting point, right? So the first one, let's look at more details. So after 120 seconds, this one, how many circles? So this one goes 15 circles, and this one goes 12 circles, and this one goes 10 circles, right? So they're all full circles. So they go back to, which means after 4 circles, they are all arrive at the starting point. Right? So number 18. So number 18. So here we start a cube, the cube roll around this check. We just need to find for the final position F, what is the number that is on the top. This problem requires a little bit spatial imagination. That means you need to have a cube in your head and you roll around. Of course, if you can also make one, right, to do the experiment, but it's not so easy to do that. So we basically need to operate this in your mind. All right, let's do several steps together. So here we have look. So the first one, if you roll 1, then you have the, because add together is 7, right? So this one on the other side. So if this is 1, on the other side will be 6. So then when you roll 8, 6 will be on the top. Now let's look at the next step. So this is 3. So on this side will be 4 because add together has to be 7. So if I roll 8, what's going to happen? So what I'm going to get is on this position. That's what I'm going to have, right? Okay. So I have 6. I have 6 on this position, and on the top will be 4. 1, 2, 3, 4, because 4 is on that. Okay, so and 2 still is right here. So this is the next step, right? So this is the next step. Then on the other side, because this is 2, so on the other side is 5, right? On the side is 5, 5. So when you roll 8, the next time the 5 will be on the top. Okay, so the 5 will be on the top. And then you just keep doing those things in your mind, and you'll find when it reaches the F, it will be 6. So just doing that in your mind. Okay. All right, so this is number 18. Now let's look at number 19. So this is probably the most confusing one because it involves negative numbers and also some algebra and squares. Okay. So what's the point? So we need 2 solutions. So I have x squared minus 2. I have squared this one equals to 4. All right. So first, let's consider this is the whole piece, right? So basically, we have something squared equals to 4. Well, something squared equals to 4, of course, obviously, we get 2 is one candidate, right? We can have this guy equals to 2, right? We have 2 squared 4. But do not forget the negative number, because or this one could also be negative 2, because negative 2 squared is also 4. It's also 4. All right. Okay, so that's how we do the multiplication of between negative numbers. So if you have 2 negative numbers, they just absorb, cancel with each other. All right, so then you say, okay, because this is, I have 2 possibilities, right? I say, okay, so now we have, I have x squared minus 2, the whole thing, this piece, either 2, or the whole piece, x squared minus 2 equals negative 2, right? 2 possibilities. For the first one, let's keep doing. So for this one, I say, okay, I just get x squared equals to 4. And for this one, x squared minus 2 is negative 2. What is x squared? X squared is 0, right? Okay, we get x squared is 0. Now, if x squared is 0, then x has to be 0. You don't have any other choices, right? So it's x is 0. Now, if x squared equals to 4, we just go back to the previous situation. We say, okay, x is 2, or x equals to negative 2. So if you combine, we have 3 options: x equal to 2, x negative 2, and x equals 0. So 3 solutions: x equal to 2, or x equals negative 2, or x equals 0. So there are 3 solutions. So here the point is, when you first look at the problem, you might feel it might look terrifying because, oh, I have square outside, in square. But the point is, you just consider this x squared, the inside one, as a whole piece. And you say, okay, so then you ask yourself, if I have whole piece squared equal to 4, what can I say about whatever inside? Well, that one has to be either 2 or negative 2, right? So then you just look at 2 different cases. And from here, you will solve, you get all possible values of x. All right. So the key point, all the starting points are right here. If I know something is square is 4, then I know that guy is either 2 or negative 2. So do not forget the negative 2. Okay, last one. Jenna has 5 different colors of candies. So one day she wants to make a combination, like 7 candies. She wants to collect, she wants to bring 7 candies to her friends. And the requirement is try to make it more colorful. She wants each color to be in this combination, right? Each color to be in every color to be in the combination. Okay, so here we have 5 different colors, right? We have the blue, we have, okay, we have blue and we have green and have orange. So 5 colors, orange and red and white, okay? Now we want to add them together. So I have plus this, plus this, plus this, plus this equals to 7. Now, of course, it's not enough if you just have 1 from each color because you cannot make 7. So then this says we have 2 situations. Either you have 2 colors, each color has 2, right? So I have 2, let's say I have 2, 2, and then you have plus 1, plus 1, plus 1, this equals 7, right? So this is the case 1. Case 1, so 2 colors, each has 2 candies, right? So like blue, blue, green, green, then 1 orange, 1 red, and 1 white, right? Okay. All right, so let's see how many situations do we have for this one? Yeah, well, you just need to decide like which 2, right? Which 2 colors. So you have 5 different colors, O, R, W. You need to choose which 2. Which 2 colors that each color has 2 candies. So we can choose this, you can choose blue and green, right? So that's this case, 2 blue, 2 green, and then orange, red. Or you can choose 2 blue, 2 red, 2 orange, 2 blue, 2 red, 2 blue, 2 white. Or you can do 2 green, 2 orange, 2 green, 2 red, 2 green, 2 white. Or you can do 2 green, 2 orange, 2 red, 2 orange, 2 white, or 2 red, 2 white. So you try all those combinations. So here the combinations is you pick 2 colors such that for those 2 colors, each color has 2 candies, right? You pick 2 colors. So from here we say, okay, we have 10 different combinations. We have 10 different combinations. Okay, so we have 10 different combinations. All right, so that's the first case. Now we have case 2. Case 2 is 1 color has 3, right? So you have, again, B plus G, orange, red, plus is 7. So 1 color, one color has 3 candies. And so like say this is, we have 3 blues. So you can have 1 green, 1 orange, 1 red, and white. This is 7. So all you need to do is choose which color that has 3 candies, right? So you need to choose which color. So you have 5 different. You have 5 different choices, right? You have 5 different choices, right? You can choose either I choose blue. I have 3 blue candies, and for all the other 1 candy. Or I choose 3 green candies and all the other 1 candy. Or I choose 3 orange candies, all the other 1 candy. Or 3 red candies and the other 1, or 3 white candies, right? So I have 5 different choices. So if you combine the 2 situations, situation 1, and then combine situation 2, if you combine together, you get 15. All right. So let me repeat. Because here we have 5 different colors, but we want to select to make 7 candies, and each color has to be present. So then, which means we have 2 situations. Situation 1, I need to choose 2 colors such that each color has 2 candy. So that will be 2 candy, 4 candy, and plus the remaining 3. So 2 plus 2 plus 3, so that's 7. Or I can choose 1 candy, and I can choose 1 color, and that color has 3 candies, right? And all the other has 1 candy. So that's 2 situations. So for the first one, I choose 2 color that each has 2 candies. So that means I have 5 colors. How many ways I can choose 2 colors? So that's as we did, I think we did before. So this is also what we did here. Okay, so it's 10 different combinations. Right, so that's 10. The second is I need to pick 1 color. It has 3 candies. So I have 5 colors. Of course, I have 5 different choices, right? So if you combine them together, in total, we get is 15. We get is 15 candies, right? Oh, sorry, 15 choices, right? For example, let's look at some combinations, right? For example, I can do let's say blue, blue, green, green, orange, red, right? 2 blue. Okay, so like I can do blue, blue, orange, 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 red, white, right? So this one, or I can simply 3 blue. Then 1 green, 1 orange, 1 red, 1 white, or I can do 1 blue, 3 green, right? Okay, 1 orange, 1 red, and 1 white, right? Okay, so these two belongs to the case 1, and these two belongs to the case 2, right? All right, so then, so in total is 50. All right, okay, so that's all, and have a nice weekend.